G'day everyone. Today what we're going to be having a look at is the cross product of two vectors. So this is different to when we originally did the dot product. You remember with the dot product or the scalar product, that gave us a numerical answer, a scalar answer. However, when we do a cross product, when we multiply two vectors together today with the cross product, you're going to get a vector as the result of this. So it's very different. The interesting thing about the cross product is that the vector that you get from the cross product is actually perpendicular to both of these two vectors. So I'll just change that to blue. So the vector that you end up with getting, like this, so A cross B, that's how we symbolize the cross product, will be perpendicular to both A, a little bit hard to draw this, and also B. So you can sort of think of that in three dimensions. That cross product will be perpendicular to both A and B. So it could look like that. There's also another thing it could look like. If that's not the only one, there'll always be two different versions, because it could also look like this. Could also go the other way. So it could be down here, because that is also perpendicular to B and perpendicular to A. If you can sort of imagine that. It's a little bit hard to on two dimensions, but that's sort of what we're looking at today. And so that's what we call the cross product, and it has lots of different uses in lots of sort of geometrical applications, like areas and equations of different things. And it's very, very handy, and we'll learn more about that as we go through. So the definition of A cross B is that it's a bit similar to dot product, is that it's the magnitude of A times the magnitude of B, this time times sine theta, and multiplied by this normal. And we'll talk about this normal in a second. And so A and B, as we've got here. So again, theta is the angle that's between A and B here. So between A and B. So theta is the angle between. And just like dot product, it's the angle between the tails of A and B. So no heads or anything like that. So just from between the tails. So the angle between the tails for theta there. And this n, you'll see it's got the unit vector hat on it there. So it's a unit vector. And n is perpendicular to both A and B as well. And you'll see that sort of come into play in a couple of slides' time, okay? So that's the angle between. Fantastic. Good. Main thing to remember is that the cross product is perpendicular to both A and B. Now, you might sort of be thinking to this, well, if there's two solutions, if there's this blue solution here and the red solution down here, then which one is it? And we've actually got a right-hand rule, so you follow the rule of thumb for that. And I'm not going to do this on the screen because it's too hard to sort of demonstrate it. But the essence of it, and your teacher will show you this, but you put your right hand in the direction of A, you curl your fingers around so they sort of point towards B, and then whichever way your thumb is facing will be the direction that the mathematicians have defined is what the official A cross B is going to be. Hope that makes sense. I'll say it again. You put your right hand in the direction of A, so pointing with the arrows. Then you curl your fingers around to point towards B, and whichever way your thumb is facing, that will be the correct A cross B. Hard to do on a screen. Hope that sort of makes sense. Okay, so let's have a look at some of the properties of the cross product. Very similar to the dot product in some ways, but very different in some others. Okay, so if we've got A cross B, is that equal to B cross A? And if we have a think about it, because of what we just said about that right-hand rule, in fact, if you do it and if your teacher shows you this, that you actually see that's actually the opposite direction. So if you do B cross A, it actually goes in the opposite direction because it turns your thumb upside down. And so what that means is that there's a big fat negative in front of there, okay? So if you change the direction of A cross B or B cross A, that makes it negative. It swaps the direction of the cross product. So that's a really important property. Another property is if you've got the cross product of itself, if you think about that, the cross product itself, sine theta, the angle between will be 0. Sine of 0 is 0. And so the actual cross product will be the 0 vector. Remember, you get a vector as an answer, unlike the scalar product. And so you get that. Similarly, if you get the cross product A with the vector 0, you also get the 0 vector. That one's obvious. And how about we've got, we always talk about sort of distributive law. So what happens if you've got sort of B plus C? What happens if you get the cross product with that? Does it distribute like we would hope and expect? And it does. Okay, so that's equal to A times B, or A cross B, plus A cross C. So that distributes out like we would sort of expect it does in algebra, if you know what I mean, like the A times the B plus the A times the C. As we see in many, many different structures. And lastly, what do constants do? If you have a constant sitting out the front of cross multiplication like this, what happens with that constant? Well, as we would hope that happens, that's equal to A times KB. So that constant can sort of move around the multiplication. It doesn't have to stay out the front of K anything. So that constant can move anywhere around. And that can sort of sit out the front of a sort of like a bracket like this as well. So that constant can move around anywhere you like. Okay, so that is totally fine. So there's a couple of, properties of how the cross product works. So the only one really that's sort of particular to the cross product that you need to be aware of that's very different to dot product is that you can't reverse the order. So be really, really careful not to be doing that in any way when you're simplifying expressions. Just be really, really careful. All right. How do we actually find the cross product? Now, you'll see that this definition up here is got lots of things that you might not be able to work out from if you're given two vectors A and B. There's lots of stuff in there that how the heck would you find it out? And there's a long-winded way to find the cross product, but the proof, I'm not going to do the proof because it's long and difficult, but the quick way is as follows, and so I'll show you this, and then in the next video I'll do a couple of examples because this will be a long video otherwise. So if you've got two vectors A, and I'll just go x1i plus y1j plus z1k, just making sure I'm not messing that up. So if you've got a vector like that, and you have vector B, which is x2i plus y2j plus z2k. All right, so if we have those two vectors, then A cross B will be equal to, and what we're going to do now is we're going to do the determinant of a matrix. And this is not because it's has got anything to do with matrices, this question, but it's because it's a great, it structures the way it comes out in exactly the way that the determinant comes out. And so it's really, it's a beautiful part of maths that these two things actually relate to each other. And you'll sort of see what I mean in a second when I put these in. So x1, x1, whoops, pardon me, y1, z1, and x2, y2, and z2. Okay, so that's as simple as it is. So if you can remember that, then you can remember everything as long as you know how to find a 3x3 determinant. Just as a quick little reminder, if you remember that if you've got the determinant of a 2x2 matrix, you'll remember that that's equal to AD minus BC. Okay, so you multiply these guys, subtract multiplying those ones. Okay, so that's how you find two-dimensional 2x2 matrix determine AD minus BC. How do you do a 3x3? I'm going to give this all to you so you can see it. You don't need to understand this because you just need to be able to follow the formula for specialist maths. So what this is equal to is you get the first thing in the top left corner, which is an I here, and I didn't put my tildes in there. I'll just do that. And then what you do is you look at that eye, right? And I'll scribble on this. So you look at that eye, and then you scribble out that column, and you scribble out that row, and you write what's left in there. And so you got Y1, Z1, and Y2, Z2. And you've got that. I'll just put it in blue because it makes it nice and regular. Okay, so that's my first one. So I've got this I. And then you do the same with J, and you'll notice I'm not going to put the, you'll see what I do here. And so then we've got J, and if you do the same thing with J, if you put a cross down, I can't sort of go back or undo, but if you draw a line down the J, so if you scribble out that, and then you scribble out the column and the row that it's in, and you write down what's left over, then what will be left over there? You'll have X1, Z1, and X2, Z2. Okay, I'll just undo that. Oh no, sorry, because it's going to undo my scribbles. Now I'll just do that again now. So it'll be X1, Z1, and X2, Z2. Okay, so we've got that. And lastly, you're going to have your K. And what would happen if you scribbled out the row and the column that K is in? You'll have X1, Y1, and what am I doing? And then X2, Y2. Now, from the nature of 3x3 determinants, what actually happens is that it follows a particular plus and minus pattern. And you don't need to know this, but all you need to know is that the I's will be positive, the J's will be negative, so there's a negative sitting out there, and the K's will be positive, and that's just to do with the sign diagram of 3x3 determinants. Don't need to know that. All you need to know is this particular formula here. And so that's how we go about finding the A cross B, how to do that. And so you'll see that once you've done that, you'll get a number for the determinants here, because to find, this determinant here, it's just Y1 times Z2, take away Z1 times Y2. And so you'll get a number for that. And so you'll end up with a nice little vector in there. And so I'm going to leave it here for this video. In the next video, what I'll do is I'll do an example of actually how to do a cross product, and we might just do a quick little example of finding the area of a triangle as well. I'll see you in the next video.